Hi students, this is Miss Went, and these notes go along with the internet activity Human Population, which we've done looking at different situations that cause the population on Earth to grow into the 7.5 billion people we have today. Okay, so you should write down a few things in your notes, but you're not going to be writing everything. Okay. So first up here, how populations change. So we have a couple vocab words we're going to put here. Populations can get larger if we have more births than deaths in a population. So if the mamas are having lots of babies and those babies and adults are surviving a long time, the population will get bigger. Also, if we have more immigration, so people or animals in a population, or even plants, moving in from somewhere else. So plants might be blown in from the wind or brought over by animals. Animals immigrate. They may have to move to look for food or water. And humans immigrate looking for jobs and opportunities and a safe place for their families. Another reason populations get longer, especially for humans, is we're living longer. We have better health care, we have better food supplies, we're safer than we maybe were a couple hundred years ago. So that's another reason. People are living longer, which means they're dying less, and kind of goes back to that. Okay. Now the opposite is true as well. Populations can also get smaller if you have more deaths than births. So if you have people dying from a disease or a natural disaster, or if there's a situation where families are not having very many babies, then the population could grow smaller. You also might have more emigration, where individuals are moving away because there's not enough food, not enough space, not enough opportunity for them where they're at, so they're going to go look for somewhere better to live. So you should have in, whoops, sorry about that, guys. You should have in your notes some reasons why populations can get larger or smaller. And you should know these words, immigration and emigration. And these words you may see also in social studies class at some time. So if you need more time to write those down, feel free to pause the video. My next screen has kind of a picture of this same thing as well. So let me show you the picture. So we have a fish population in the center here. And this fish population can get larger when new individuals are born, or if you have fish moving in from somewhere else. And then the population will get smaller if fish are leaving or they're dying. And if we fill in the blanks there, those are our vocab words. So births and immigration will make the population bigger. Emigration and death will make the population smaller. So you should have those 4 conditions in your notes and how they affect population. So I'm going to move on to the next slide, but remember, you can always pause the video if you need to write. That is why these videos are kind of useful, because you have the ability to pause or move forward. Now in your notes, I want you to sketch this red line as a graph. And this shape on the graph is called exponential growth. And you will see it in a math class at some point. You may see it in an economics or a business class. And you may see it in a physics or chemistry class as well. So it's a pretty common shape for graphs. And exponential growth can happen for populations. So we want to talk about that. So we want you to know the shape of this line. It's a common shape used for lots of different subjects, not just biology. So you should know that this line shape is exponential growth. Don't worry about the numbers, that's not important. So exponential growth is going to happen under ideal conditions with unlimited resources, and the population will grow exponentially. So if you start with a population of just a couple individuals, it's going to take a little while to get bigger and bigger, but it's going to reach suddenly a point where the growth is really fast, and then it shoots up at a very high rate of growth. Okay, so here's a place on the graph where that change is happening. The population is rapidly increasing, and that increase continues, and the line gets steeper and steeper. Now up here it says under ideal conditions. Well, what does that mean? Ideal conditions are when this population, whether it's humans or rabbits, trees, whatever this organism is, it has enough food, so it doesn't have to worry about that. It has enough space to spread out and do what it needs to do. There's no predators eating it. There's no disease threatening it. It's a safe environment. So they can just live their happy little lives and have all the babies they want, and the population is just going to explode. Okay? And this has kind of been happening with humans the last 100 years. Okay, now not every human has all these ideal conditions, right? But the conditions are a lot better than they were back in the 1600s or 1700s. So the conditions have improved. So our population has been doing this exponential growth. Okay, now, but I want to show you an example of this with bacteria. So, oops, sorry, let me go back a slide. This little picture down here is bacteria. These are E. coli, which live in your intestines and help you break down food. And they're real simple creatures. They'll live for like 4 hours. And then when they're ready to reproduce, they just divide in half, and then you have 2 bacteria. So this probably used to be 1 bacteria that grew big, and it split into 2. And after about 4 more hours, each of these 2 will also split in half. That's how they reproduce. Just 1 parent, and the baby is exactly identical to the parent. So bacteria can grow really quickly, and we can see that modeled in the lab. So let's say you start with 1 bacteria. 4 hours go by. Now you have 2. By the way, guys, you do not have to write this down, okay? Another 4 hours go by. Both of those divide. Another 4 hours. Both of those divide. And, you know, these numbers aren't too big, so our graph is fairly flat. But then we get to a point where, you know, when we double again, that's a pretty big jump in numbers. That's a really big jump. And that's a huge jump. And so on and so on. So you can see if I was graphing this, this would be like 1, this would be 2, this would be 4, you know, a little higher up. This would be like 8, 16. Oh, we're getting significant here. 32, 64, 128. You can see how the line would change really quickly. The numbers all kind of start off small, but then they suddenly start jumping larger and larger just because it's doubling every time. And that's what happens with exponential growth. Okay, so you don't have to write these numbers down. We just want you really familiar with this shape. That sometimes it's called a J curve because it kind of looks like a capital letter J with that curve and then a kind of the straight part on the right side. All right. So that's exponential growth. But eventually, those bacteria are going to run out of food and space. They can't grow forever until they fill the entire planet Earth. That's not going to be a thing. So if we go long enough, our graph is going to change into this shape here. And you should sketch this in your notes as well. This is called logistic growth. And let me explain it to you, and then I'll give you a chance to do some writing here. This is when a population's growth slows down, and then the growing actually stops following a period of exponential growth. Okay, so if we put some arrows in here, phase 1, this part here is exponential growth. There's our J curve right there. But then we start running out of supplies. It's harder to find food. It's harder to find space. So the growth starts slowing down and the graph starts bending the opposite way. And then we reach a point where the graph is kind of a straight line. And there might be some little wiggles up and down, but it's generally flat. This is called logistic growth, the whole thing. And this is what all populations will do. If you throw a bunch of flower seeds in your backyard, maybe the first year there's just a couple, and then there's more, and there's more. And if there's nothing eating them and nothing stopping them, they're going to grow and grow and grow and spread out in your whole yard. But then eventually the yard is full. There's nowhere else to grow, so their population will just stay the same, filling the whole yard. You know, they can't go into the street. They can't grow on top of your roof. Okay, so all populations will go through this pattern. Now, if there's something like a natural disaster, like a volcano or a forest fire, if there's a new virus that comes through, that could alter the shape, absolutely. But under most normal circumstances, all populations are going to do this kind of shape. Okay, so take a moment. You can pause the video if you want to, and just kind of sketch the shape in here. You don't need to label the phases really if you don't want to, but we just want you to know that's logistic growth. Totally normal, and it happens after the exponential growth that we had at the beginning. Okay, so pause the video if you need to. And I'm going to move on to the next slide. And that's going to deal with that flat part at the top. And that is called the carrying capacity. Okay, so where we have this flat part, that is the spot that has the maximum number of individuals. So the graph never really gets higher than this because that's how many the environment can support. There's enough food for this many people, and that's it. If a whole bunch more people move in, they're going to die of starvation, and the graph will go back to this flat point. And you maybe saw this with one of the simulations, the gizmos that we did online, where we saw this change there. Okay, we could make the graph go up higher, but it would almost always go back to this equilibrium point, this carrying capacity point. Okay, so this is where the environment has enough food, enough water, enough space, where everybody can kind of be healthy and everything just stays in balance. Okay, so on your gizmo, it was called the equilibrium. Everything was equal. We also use the phrase carrying capacity. So either one would be a good phrase for this kind of spot on the graph. Okay. Now humans, we're not here for this spot on the graph yet. How many humans do you think planet Earth can support? I don't have an answer for you because scientists are still working on it. All right, let's see what's next here. Let's talk about humans. Okay, so all those graphs would work for humans and other populations, but humans, you know, that's us, so let's look at them a little more detailed. So as of right now, there's about 7.8 billion humans on planet Earth. And our population has been growing exponentially for the past 200 years. You have been working on an activity online where you were looking at some little diamonds on the timeline that showed some things that helped the population grow or some things that made the population slow down growing too. But here are some reasons why the human population is growing fast. You don't have to write them all down, but I can tell you, you will have a question on your test or quiz that'll say, list some reasons why the human population has been growing. Okay, and there's lots of reasons, so there's lots of right answers. So make sure that you do know a couple things, even if you don't write them all down. So better sanitation is one. We are washing our hands better. Doctors, when they are treating patients, it used to be very common for them to go all day and never wash their hands. They may touch 30 bleeding people with urine and feces and open cuts and never wash their hands before they touch the next person or deliver the next baby. Okay, that would spread a lot of disease. So we know better now. We have better sanitation, better cleaning. We use toilets. We don't just go to the bathroom wherever it's convenient. And we clean the water in the toilets before we put it back in the rivers, right? We are not bathing and drinking the same water that the animals on the farm are using. So all that is causing less disease to be spread. We have better health care. There are more doctors, more hospitals available to people. It is definitely not perfect. Not everybody on the planet has equal access to health care, but it is better than it was 200 years ago. We also have new medications for things like diabetes and heart conditions and cholesterol to help us be healthy and control some of those diseases. We have vaccines to prevent disease. So if you go get a flu vaccine, if you had to get a polio vaccine before you started school, eventually we'll have a coronavirus vaccine. Those will prevent people from getting sick. And it also prevents those people from spreading the sickness to their neighbors and their family members too. We have more technology to grow food. We have better tractors. We have genetically modified seeds. We have plastic and metal that's very strong and we can use for many years. So that helps us grow more food. We can store food safely. We have refrigerators and freezers. So the food that we harvest in September is still able to be eaten in March next year without making us sick. And we also have the ability to move food. We have cars and trains to move food from one place to another. And we also have safety laws and equipment. We have fire safety equipment. We have sprinklers in tall buildings and fire trucks and fire alarms. We have laws so people working in factories have safe places to work and they don't die on the job. We have safety equipment for farmers and we have safety equipment in our cars. So during accidents, we are not injured as badly as we could have been. So all these things are allowing us to live longer. It's preventing people from dying at younger ages, so our population is growing. Okay, so you should know a few reasons why the human population is growing. You don't have to memorize all of these, but you should be able to come up with 3 or 4 out of your brain. So you should write down, 3 or 4 that make sense to you and make sure you review them before your quiz. So pause the video to write if you need to. I'm going to move on. We have, I think, 2 slides left here. When population goes up, the greenhouse gases also go up. This is a problem we have with the human population getting bigger. So the blue line here is the human population. And as that goes up, this black line is our greenhouse gases. It matches. The more humans we have, the more greenhouse gases we have. So that could lead to some global warming and some changes in our weather patterns. That could make it harder to grow food in some places. And it could make it harder to live in some places on planet Earth. And if we have more people, we're going to need more places to live, not less places to live. So this is a concern. Okay, if this population line keeps going up, is this greenhouse line going to go up and match it? Or is there a way we can get this thing to stop going up? That's a concern that a lot of people have, including myself. What is the carrying capacity of planet Earth? Right? So we said carrying capacity, is how many people, how many humans we can hold on planet Earth and still have enough food and space and water. And I don't know the answer to that. There's lots of models. Part of it depends on the life you want to live. Would you like to live in one of these cities? If we keep adding people to planet Earth, the cities are going to get larger and larger and larger, more apartment buildings that are 40, 50 stories tall, little apartments. You know, less trees, less green space, less parks because we need places to put all these people. So what's the carrying capacity of Earth? How many people can we feed? How much space do we need to support that people so we can grow food for them? Do we need national parks for wildlife? Or is that something that we'll have to not have because we need the room for people? Okay. What about water and soil or natural resources like oil? Okay. These things, how much does each person need? And what's going to run out first? What do we have to fix first? Okay. So there's people out there working on trying to figure these questions out. And the last question is the most important. Okay. So some of the jobs that you guys are going to be going into, you know, 5 or 10 years from now, haven't even been invented yet because people are working at solving these problems. And hopefully some of you guys can solve these problems too. What are, think about what problems do you feel we need to solve? What problems are you interested in solving, and can you make a career out of that? That's something to kind of think about with all these big ideas, right? It's, these are concerns we have, but we need to focus on how to make it better. How can we fix the problems? Okay, so with that idea, this is our last slide for this. The most important thing in these notes that you need to know for your test, the shape of those two graphs, the exponential growth and the logistic growth, and some reasons as to why the human population is growing so fast. Okay, and it doesn't mean that the human population growing fast is a bad thing. That means we've done a good job of feeding people and taking care of people's healthcare needs. Okay, so some of that is a very good thing. We just need to make sure we keep looking forward and trying to solve problems we see coming down the line and trying to just make the world the best place we can. Okay, so I'm going to end the notes here. If you have to finish your online activity called Human Population and Climate Change, please go do that now. And as always, if you have any questions, let me know. Have a great day, guys.